Chapter 2, A Tour of the Book. The words output, unemployment, and inflation appear daily in newspapers and on the evening news. In this chapter, we define these words more precisely. The chapter also introduces concepts around which the book is organized: the short run, the medium run, and the long run. Chapter 2 Outline. Section 2-1 looks at output. Section 2-2 looks at the unemployment rate. Section 2-3 looks at the inflation rate. Section 2-4 introduces two important relations between these three variables: Okun's law and the Phillips curve. Section 2-5 then introduces the three central concepts around which the book is organized: the short run, the medium run, and the long run. Section 2-1 Aggregate Output. National income and product accounts were developed at the end of World War II as measures of aggregate output. The measure of aggregate output is called Gross Domestic Product, GDP. How would you define aggregate output in the economy? Section 2-1 considers an economy with two firms: Steel Company Firm 1 and Car Company Firm 2. Steel Company's revenues from sales are $100 and the car company's revenues from sales are $200. Is aggregate output the sum of values of all goods produced, that is $300, or just the value of cars, that is $200? Steel is an intermediate good, which is a good used in the production of another good. We can calculate the value of aggregate output in three different ways from the information given. Three ways of calculating GDP. 1. GDP is the value of final goods and services produced in the economy during a given period. In the example given, the value of cars produced is $200. Cars are the final good produced, whereas steel is an intermediate good used in producing steel. So only the value of the final good produced will be counted in the GDP, which is the revenue from car sales, equal to $200. If the revenue from sales of steel is also included, it would lead to double counting. 2. GDP is the sum of value added in the economy during a given period. The value added by a firm is the value of its production, revenue from sales, minus the value of intermediate goods used in production. In the two-firm example, the value added at each stage of production equals $100, value added by the steel firm, plus $100 value added by the car firm, equal $200. So far, we have looked at GDP from the production side. 3. GDP is the sum of incomes in the economy during a given period. Aggregate production and aggregate income are always equal. From the income side, value added in the two-firm example is equal to the sum of labor income or wages earned at the two firms, $80 plus $70 equals $150, and capital or profit income earned by the two firms, $20 plus $30 equals $50, that is $200. All three measures of aggregate output give us the same answer: GDP equals $200. Aggregate output, nominal GDP versus real GDP. Nominal GDP is the sum of the quantities of final goods produced times their current price. Nominal GDP increases for two reasons. The production of most goods increases. The price of most goods increases. Our goal is to measure production and its change over time. Real GDP is the sum of quantities of final goods times constant, not current prices. Aggregate output. Example above shows how nominal GDP and real GDP are calculated. Nominal GDP for 2008 in 2008 dollars equals 10 cars times $20,000 per car equals $200,000. Nominal GDP for 2009 in 2009 dollars equals 12 cars times $24,000 per car equals $288,000. Nominal GDP for 2010 in 2010 dollars equals 13 cars times $26,000 per car equals $338,000. Real GDP in 2008 in 2009 dollars equals 10 cars times $24,000 per car equals $240,000. Real GDP in 2009 dollars equals 12 cars times $24,000 per car equals $288,000. Real GDP in 2009 dollars equals 13 cars times $24,000 per car equals $312,000. Real GDP is calculated using constant or base year prices, which in this example is 2009 prices. For more than one good, relative prices of the goods are natural weights for constructing the weighted average of the output of all final goods. Real GDP in chained 2009 dollars reflects relative prices that change over time. The year used to construct prices is called the base year. In the base year, nominal GDP and real GDP are always equal. From 1960 to 2014, nominal GDP increased by a factor of 32, as shown by the blue curve in Figure 2-1. Real GDP increased by a factor of about 5, as shown by the red curve. Nominal GDP and real GDP are always equal in the base year, which in this case is 2009, so the two curves cross in 2009. For years before 2009, real GDP curve lies above nominal GDP, since 2009 prices being used to find real GDP values for those years are higher. Nominal GDP is higher than real GDP for years after 2009 as prices continue to rise. Nominal GDP is also called dollar GDP or GDP in current dollars. Real GDP is also called GDP in terms of goods, GDP in constant dollars, GDP adjusted for inflation, or GDP in chained 2009 dollars, or GDP in 2009 dollars. Henceforth, when we say GDP, we will refer to real GDP. YT will denote real GDP in year T. Nominal GDP and variables in current dollars will be denoted by a dollar sign in front of them, for example, $YT. Growth rate of US real GDP from 1960 to 2014 is shown in Figure 2-2. Growth in year T is given by YT minus 1 divided by YT minus 1. Real GDP in year T minus real GDP in year T minus 1, and the difference divided by real GDP in year T minus 1. Since 1960, the US economy has gone through a series of expansions interrupted by short recessions. The 2008-2009 recession was the most severe recession in the period from 1960 to 2014. Focus: real GDP, technological progress, and the price of computers. The Department of Commerce deals with changes in the quality of existing goods like computers with an approach called hedonic pricing, which treats goods as providing a collection of characteristics. The quality of new laptops, computing services, has increased on average by 18% a year since 1995. The dollar price of a typical laptop has also declined by about 7% a year since 1995. This implies that laptops' quality-adjusted price has fallen at an average rate of 18% plus 7% equals 25% per year. The unemployment rate. To understand what the unemployment rate tells us, it is important to know what is meant by the terms employment, unemployment, and the labor force. Employment is the number of people who have a job, even if it is part-time. Unemployment is the number of people who do not have a job but are looking for one. The labor force is the sum of employment and unemployment. The unemployment rate. The unemployment rate is the ratio of the number of people who are unemployed to the number of people in the labor force. Unemployment rate equals number unemployed divided by number in labor force, or unemployment rate equals number unemployed divided by sum of number employed plus number unemployed. Most rich countries rely on large surveys of households to compute the unemployment rate. The U.S. Current Population Survey, CPS, relies on interviews of 60,000 households every month. A person is unemployed if he or she does not have a job and has been looking for a job in the last 4 weeks. Those who do not have a job and are not looking for one are counted as not in the labor force. Discouraged workers are those who have given up looking for a job and so are no longer counted as unemployed. The participation rate is the ratio of the labor force to the total population of working age people. Because of discouraged workers, a higher unemployment rate is typically associated with a lower participation rate. Why do economists care about unemployment? 1. Direct effect on the welfare of the unemployed, especially those remaining unemployed for long periods of time. 2. A signal that the economy is not using its human resources efficiently. And also, very low unemployment can be a problem as the economy runs into labor shortages. U.S. unemployment rate from 1960 to 2014 is shown in Figure 2-3. Since 1960, the U.S. unemployment rate has fluctuated between 3 and 10%, going down during expansions and going up during recessions. The effect of the recent crisis is highly visible, with the unemployment rate reaching close to 10% in 2010, the highest such rate since the early 1980s. Effects of unemployment on happiness are shown in Figure 1. Results of the German Socio-Economic Panel survey suggest that 1. Becoming unemployed leads to a large decrease in happiness. 2. Happiness declines before the actual unemployment spell. And 3. Happiness does not fully recover even 4 years later. The inflation rate. Inflation is a sustained rise in the general level of prices, the price level. The inflation rate is the rate at which the price level increases. Deflation is a sustained decline in the price level, negative inflation rate. The inflation rate can be measured using the GDP deflator. The GDP deflator in year T, PT, is the ratio of nominal GDP to real GDP in year T. It is called an index number, 1 in 2009, which has no economic interpretation. The rate of change has a clear interpretation. The rate of inflation can be calculated as pi t equals pt minus 1 divided by pt minus 1. Inflation rate equals GDP deflator in year T minus GDP deflator in year T minus 1, and the difference divided by GDP deflator in year T minus 1. Defining the price level as the GDP deflator implies a simple relationship between nominal GDP, real GDP, and the GDP deflator. $YT equals PT times YT. Nominal GDP is equal to the GDP deflator times real GDP. The rate of growth of nominal GDP is equal to the rate of inflation plus the rate of growth of real GDP. The more commonly stated measure of inflation is the Consumer Price Index, or CPI. The set of goods produced in the economy is not the same as the set of goods purchased by consumers because some of the goods in GDP are sold not to consumers but to firms, to the government, or to foreigners. Some of the goods bought by consumers are not produced domestically but are imported from abroad. The Consumer Price Index, CPI, is a measure of the cost of living. The CPI is published monthly by the Bureau of Labor Statistics, BLS. The CPI gives the cost in dollars of a specific list of goods and services over time. The inflation rates, computed using either the CPI or the GDP deflator, are largely similar as shown in Figure 2-4. The CPI and GDP deflator move together most of the time. Exception. In 1979 and 1980, the increase in the CPI was significantly larger than the increase in the GDP deflator due to the price of imported goods, oil, increasing relative to the price of domestically produced goods. Pure inflation is proportional increase in all prices and wages. This type of inflation causes only a minor inconvenience as relative prices are unaffected. Real wage measured by goods rather than dollars, would be unaffected. There is no such thing as pure inflation. Why do economists care about inflation? 1. Inflation affects income distribution when not all prices and wages rise proportionally. 2. Inflation leads to distortions due to uncertainty, some prices that are fixed by law or by regulation, and its interaction with taxation, bracket creep in taxes. Most economists believe the best rate of inflation to be a low and stable rate of inflation between 1 and 4%. Output, unemployment, and the inflation rate. The relationship between these three major economic indicators can be understood with the help of Okun's law and the Phillips curve. Figure 2-5 illustrates Okun's law. It shows the inverse relation between changes in the unemployment rate and output growth in the United States for the period 1960 to 2014. Output growth that is higher than usual is associated with a reduction in the unemployment rate. Output growth that is lower than usual is associated with an increase in the unemployment rate. Okun's law is a relation first examined by U.S. economist Arthur Okun. In Figure 2-5 shown on the previous slide, the line that best fits the points is downward sloping. The slope of the line is negative 0.4, which implies that, on average, an increase in the growth rate of 1% decreases the unemployment rate by 0.4%. The line crosses the horizontal axis where the output growth is 3%, meaning that it takes a growth rate of 3% to keep unemployment constant. Figure 2-6 illustrates Phillips curve, showing the negative relationship between changes in the inflation rate and the unemployment rate in the United States 1960 to 2014. A low unemployment rate leads to an increase in the inflation rate. A high unemployment rate leads to a decrease in the inflation rate. The Phillips curve is a relation first explored in 1958 by New Zealand economist A.W. Phillips. Figure 2-6 plots the change in the inflation rate against the unemployment rate along with the line that best fits the points. The line is downward sloping, meaning that higher unemployment leads on average to a decrease in inflation and vice versa. The line crosses the horizontal axis where the unemployment rate is equal to about 6%, meaning that inflation typically increased when unemployment was below 6%. The short run, the medium run, and the long run. In the short run, example a few years, year-to-year movements in output are primarily driven by movements in demand. In the medium run, example a decade, the economy tends to return to the level of output determined by supply factors such as capital stock, the level of technology, and the size of the labor force. In the long run, example a few decades or more, the economy depends on its ability to innovate and introduce new technologies and how much people save, the quality of the country's education system, the quality of the government, and so on. A tour of the book. The core. Chapters 3-6, the short run and the role of demand. Chapters 7-9, the medium run and the supply side. Chapters 10-13, the long run. Extensions. Chapters 14-16, expectations and implications for fiscal and monetary policy. Chapters 17-20, open economy and implications for fiscal and monetary policy. Back to policy. Chapter 21, general issues of policy. Chapters 22 and 23, the role of fiscal and monetary policies. Epilogue. Chapter 24, History of Macroeconomics and how macroeconomists have come to believe what they believe today. Figure 2-7 illustrates the organization of the book. Appendix: the construction of real GDP and chain-type indexes. In this slide, you see how rate of growth of nominal GDP is calculated. We take nominal GDP in year 1, $30, minus nominal GDP in year 0, $20, divide the result, $10, by nominal GDP in year 0, $20. Result shows 50% growth rate. The construction of real GDP and chain-type indexes. If year 0 is used as base year, rate of growth of real GDP is 25%. If year 1 is used as base year, rate of growth of real GDP is 20%. Problem: which base year should one choose? In December 1995, the U.S. Bureau of Economic Analysis shifted to a new method with 4 steps. 1. Construct the rate of change of real GDP between 2 years in 2 different ways, using the price from year T as a set of common prices, using the price from year T plus 1 as the set of common prices. 2. Construct the rate of change of real GDP as the average of these 2 rates of change. 3. Construct an index of the level of real GDP by linking or chaining the constructed rates of change for each year. 4. Multiply this index by nominal GDP to derive real GDP in chained dollars.